In this video, I will show you how to determine whether a given sequence is increasing or decreasing or not monotonic at all. So I'm going to show you two different methods. And in method one, we're going to establish the inequality between Cn and its successor. So if Cn is greater than its successor, then the sequence is decreasing. If Cn is less than its successor, then the sequence is increasing. So as of right now, we don't know what the inequality in between, but plugging in the expressions for Cn and its successor will give us the following inequality to consider. Again, it's not clear how the inequality goes in between these two expressions, so we're going to simplify it a little bit. Still not clear, so I'm going to multiply both sides of the inequality by n plus 1, n plus 2. So if I multiply both sides by n plus 1, n plus 2, because it's positive, the inequality will not change. Now on the left hand side I will have n plus 2 times n minus 1. On the right side I have n times n plus 1. Still not clear, so let's go ahead and distribute everything. So on the left side we have n squared plus n minus 2. On the right side we have n squared plus n. And by taking away n squared and n from both sides, we end up with the following two sides to compare. Clearly negative 2 is less than 0, and therefore the inequality in all of this inequalities goes this way. Therefore Cn is less than its successor, and therefore the sequence is increasing. Alternatively, we can do another method. In this method we consider a function, a continuous function on which this sequence resides for all n greater or equal to 1, and it's continuous on this interval, and we want to figure out whether this function is increasing or decreasing. And to figure out whether this function is increasing or decreasing, we have to find the derivative. So derivative of this function is, using the quotient rule, it's going to be x plus 1. So 1 times x plus 1 minus 1 times x minus 1 divided by x plus 1 squared. In the numerator we have now 1 plus x minus x plus 1, so it's 2 over x plus 1 squared. And this expression is always positive for all x values greater than 1. So it's always positive. Therefore, the function is increasing. And if the function is increasing, the sequence that resides on this function must be also increasing. So here I presented two different ways to show that a given sequence is increasing.